Welcome to Operation Research, chapter number 2, Linear Programming. Here we are going to learn the simplex method. Here we are going to develop linear programming from the given hypothesis with multiple variables. Then we are going to apply the simplex algorithm to solve linear programming problem. And finally, we are going to interpret the simplex tabular. Now let's see why we are going to use simplex method. When decision variables are more than 2, it is always advisable to use simplex method. The simplex method is not used to examine all the feasible solutions. It deals only with a small and unique set of feasible solutions. The set of vertex points of the convex feasible space contains the optimal solution. Let's get an idea with regard to the key terms in simplex method. First one is entering variable. The variable which has the highest positive value under Cj minus Zj row represent the entering variable. Pivot column is the column of the entering variable. Then the leaving variable. This is the variable which shows the lowest cost figure under the solution quantity minus reflecting number. Pivot row. The row that represents the leaving variable is the pivot row. Pivot element is the intersecting point of pivot column and pivot row. Now you can see the simplex table. In the simplex table, Cj reflects the values for variables in the objective function. The Cb reflects the values for basic variable. The basic is the variable value for the solution variable. Then the solution is the value for different solutions in the basic variable. Here is a J is the total profit or the total cost, whereas Cj minus Zj is the new value which can be added by different variables in the objective function. Now let's see what are the steps of formulating simplex model. The first one is set up the initial solution. The second one is test the optimality. Third one, we are going to identify the leaving variable and then we are going to identify the entering variables as well. The fifth one is we are going to develop the new solution and we are going to test the optimality under Cj minus Zj greater than or equals to 0. Then finally, we are going to do the interpretation for the solution. Now we will use this question to understand how to solve a linear programming problem. Please look at the question carefully. Now based on the given data, we are going to formulate the linear programming model. Here the first one is deciding the decision variables. Here I am assuming x and y as the decision variables. X represent number of A models produced weekly and Y represent number of B models produced weekly. Now let's decide the objective function. Here in this question they have given the profit. Therefore the objective should be maximize profit. According to that, I am taking profit maximization equals to 3x plus 4y. Then the next one is deciding the constraints. Constraints are limiting factor. In this question, the available hours are the limiting factors. Because of that, upper capacity will be limited to 80 hours in the grinding section and 180 hours in the polishing section. Therefore, my first constraint would be 4x plus y, but since the hours are limited to 80 in the grinding section, it should be less than or equal to 80. Then the next one is the polishing. So in the polishing one, you can see it should be 2x plus 5y, but since the polishing hours are limited to 180, it is less than or equal to 180. Now the final one is we have to decide the non-negativity constraint. We know that since it's a production, both products should be greater than or equal to 0. We can't see any negative constraints or negative products in the manufacturing. Now, based on the linear programming model, we have to develop the simplex model. In the simplex model, first one is we have to set up the slack variables for unused capacity. So, I'm using S1 to represent unused grinding hours and S2 to represent unused polishing hours. Here, we are going to add these slack variables into the objective function. Therefore, 3x plus 4y represent the profit, whereas S1 and S2 represent the unused grinding hours and unused polishing hours. Now, let's decide the constraints. So, here we know that when we are producing the goods, it will consume 4x plus 2y, whereas the unused capacity is represented from the S1. Therefore, the total capacity come up with the used capacity of yellow color plus the unused capacity of S1. Therefore, the total hours equal to 80. Here, we don't have any lesser than or greater than signs. In the next one, in the polishing section, what you can note is the full utilization of polishing section for products is represented with the red color 2x plus 5y, whereas the unused capacity represented with the S2. So, the both used and unused capacity come up and add up to 180 hours. Therefore, here also we are going to use equal sign. Now, when we are adding the non-negativity constraint, we are assuming that there must be unused grinding hours as well as unused polishing hours. Therefore, we are going to rewrite it again as x, y, s1, s2, but everything should be equals to 0. Now, let's closely look at the simplex table again. Now, I am going to explain the initial solution. In the table, in the first one, we are going to do is we are going to put the objective function. As I mentioned earlier, the Cj value represents the values in the objective function. Here, since in the objective function we have 3x, what we are going to use is we are going to put 3 on the top of the x and y on the top of the y. Since we don't have any unused capacity there, we are going to put 0 in front of S1 and on the top of S2 we are going to put 0. The next one is we are going to identify the constraints. In our first row, if we are going to take the first constraint, what we are going to use? We are going to use the grinding capacity constraint. In the grinding capacity, what we can see, we have 4x plus 2y and S1 equals to 0. So, in the table, what we are going to put? We are going to put 4 under x1, 2 under y. So, then under S1, we are going to put 1 and under S2, we are going to put 0. Then, the total solution represents the total capacity by used and unused one. Therefore, we are going to insert S1, the first slack variable, into our initial table. Now, in the next one, what we are going to use, we are going to put the next constraint. That is my limitation of polishing hours. In the polishing hour, we can see that is 2x plus 5y plus S2 equals to 180. Here we are going to put 2 under x and 5 under y. since we don't have any slack 1 variable, we are putting 0, and under S2, since we have one slack variable, we are going to put that. Now, for the table, initial solution table, we are going to take S2 inside, and we are going to put the total capacity under the solution section. Since we don't have any profit figure, Zj value would be 0 in each and every cell. Now, when we are going to take Cj minus Zj figure, we can see in the first one, we can see automatically 3. In the second one, we have 4. Whereas for S1 and S2, we have zeros. Based on the table, our first option is we have to identify the pivot column. Pivot column represents the highest Cj minus Zj figure. In this one, it is under Y column with the value 4. Now, in the next one, we are going to identify the pivot row. To identify the pivot row, we need the ratio. So, in this ratio, what we are going to take, we are going to take the solution value and we are going to divide it with the pivot column value. So, you can see in the first slack variable 1 is 1, the solution value is 80 and we are going to divide it into the pivot column value 2. The answer is 40. Now, in the next one, we are going to take the S2 value, right? So, we are going to put this S2 value and we are going to divide it with the value in the pivot column, that is 5. Then the ratio come up as 36. So, based on this, now we are going to identify the pivot row. Pivot row is the value with the lowest ratio. So, under that, our pivot row is the second row. In the first one, we have identified the pivot column in the yellow color area, and in next one, based on the lowest ratio, we have identified the pivot row. Now, with the intersection point, we are going to identify the pivot element. Here, the pivot element is 5. So, based on the pivot element, what we are going to do, we are going to identify the leaving variable. Here, the leaving variable is S2. And now we are going to decide what is the entering variable. Here, we are going to enter Y into the simplex table. Now, next option is we have to identify what are the new values for the new row. So, here, new solution values can be identified by leaving variable value divided by the pivot element. Here, the leaving variable is Z2. So, what we are going to do, we are going to divide all the values in the leaving variable with the pivot element. 180 divided by 5, which gives 36. Then 2 divided by 5, 5 divided by 5, 0 divided by 5, as well as 1 divided by 5. Now, after finding the values for the new solution, that is where for our leaving variable and entering variable, what we are going to do is we are going to find the values for the other rows as well. So here in this one, the other row is the S1 row. So for the S1 row, we are going to find the new row values. To find the new row values, we are having a formula, that is, it should be the old value minus pivot element into the new solution. So let's see. Here, in the first one, the old value for the solution is 80. Now, in this row, the pivot element is 2. So, we are going to take 2 and we are going to multiply it with the new solution value. So, in this one, new solution value is 36. Now, we are going to take the second one. In the second one, the old value is 4 with the pivot element of 2. We are going to take the new solution value. So here the new solution value is 2 divided by 5. Let's see the third one. In the third one, the old value is 2. Now that is same as the pivot element value. So we are going to take 2 and we are going to multiply it with the new solution value. That is 5 divided by 5. Then the next one. In the next one, the old value is 1. So what we are going to do, we are going to multiply it with the pivot element of the row, and what we are going to do, we are going to multiply it with the new solution value. Likewise, for 0 also we are going to do the same. So now in the table 1, you can see we have taken the y as the entering variable and we have replaced the values with the new solution values. And here we have put the value for the basic solution with our profit function. And then we have used the new row values for S as well. Next one is we are going to find the values for Cj. Here in the first one we can see the calculations for the basic variable is 4. So the basic variable multiplied with the new value, we can see it as 144. Then what we are going to do is we are going to multiply each and every value of the solution with the basic variable value. So now you can see how we are going to multiply it. Since we have calculated the Zj values, the next step is we have to calculate the Cj minus Zj values. Cj value represent in the top of the table, that is 3400. From these values, we have to deduct the Zj values. Accordingly, you can see the Cj minus Zj figures in the triangles. Now, the highest point of Cj minus Zj represent the pivot column. Now, next step is we have to identify the pivot row. The pivot row is the lowest value of the ratio. This ratio is calculated from the solution divided by the pivot value of each row. In the first one, it is 8 divided by 32, 3.2, and in the next one, it is 36 divided by 2 by 5. So, the lowest ratio is 2.5. Therefore, the intersection point is 3.2. That is our pivot element. So here we are going to identify our leaving variable as S1 and entering variable as X. In the next step, we are going to identify the new solution. New solution is the leaving variable divided by the pivot element. So here we are getting the value as 2.5, 1, 0 and 1 divided by 3.2, as well as the final value is minus 0.4 divided by 3.2. What we are going to do is we are going to find the new row values. To find the new row values, we are going to replace for the y row, our second row. In the second row, you can see I have colored it with the gray color, so you can easily identify the row. Now, in that one, you can see 36, 2 divided by 5, 1, 0, 1 divided by 5 as old values. Now we are going to find new values for this row. For that one, we have to deduct the old values from the pivot element into new solution. So here you can see the new solution with the blue color. So what we are going to do is we are going to take the pivot element of the particular row. In this one, it is 2 divided by 5. Now let's calculate the first one. In the first one, what we are going to do is we are going to take the old value. That is 36. Then from this 36, we are going to deduct the pivot element into new solution. That is 2 divided by 5 into 2.5. Then the final answer is 35. Now let's see the second one. In the second one, the old value is 2 divided by 5. Then our pivot element also the same. Now I'm going to multiply it with the new solution value. So ultimately my answer would be 0 because 2 divided by 5 minus 2 divided by 5 is 0. Now let's see the next one. In the next one, I'm going to take the old value as 1. Then I'm going to take the pivot element, multiply with the new solution value. So here the final answer is 1. Likewise, you can calculate for S1 as well as S2. Substituting the values, you can see the new solution value as well as the replaced value for the old variables as well. In this table, you can see our slack variable S1 and S2 has been replaced by the basic variables. So in the solution section, you can see there are 2.5 units of X and there are 35 units of Y. As well as you can see the relevant profit for X as well as for Y. So now we are going to calculate the total profit. It is the combination of the per unit profit into the total quantity. Therefore, we are going to take 2.5 into 3 to get the total profit of X and 35 units of Y into its per unit profit of 4. Then the total profit of Y as 35 into 4. Then by combining the total profit of X and Y, we are getting 147.5. Calculate this is a J value for X, Y, slack 1 as well as slack 2. Here is a J value for X is 3 and is a J value for Y is 4. Whereas when it comes to slack variable 1, we can see there is 0.3125 units for X and minus 0.125 for Y. So therefore, we are going to take the combination of these two. In order to get the combinations, we are going to multiply slack variable 1 x figure with its profit of 3 and slack variable 1 y figure with its profit of 4. Then the total value is 0.375. Now the next one is we are going to take the value for S2, slack variable 2. Here what we are going to do is we can see for x there is 0.125. So we are going to multiply this value with its profit figure of 3 and then we are going to multiply the figure for y 0.125 with its profit figure 4. Then the ultimate value is 0.875. We are going to do is we are going to deduct the Cj value from Zj value. Accordingly, we can see there is 0x, 0y minus 0.4375 for slack 1 minus 0.0875 for slack 2. Time to check for the optimality. In the optimum solution, the Cj and Zj values must be 0 or negatives. So here in this table, it is zeros for x and y. For S1, it is minus 0.4375 and for S2, it is minus 0.0875. Now, what we are going to do for these two prices? These two prices are known as shadow prices. Shadow prices means these are the maximum prices that can be paid to the resource in order to achieve the objective function. Manufacturer can earn a maximum weekly profit of rupees 147.50 by producing 2.5 units of Model A and 35 units of Model B. Also, we have to interpret the shadow prices. Here, the objective function can be further increased by 44 cents if one additional grinding hour is made available, and it can be further increased by 88 cents if an additional polishing hour is available. Now this is the end of the session. Hope you have gained some knowledge with regarding the simplex method, how we are going to develop the initial table, then how we are going to optimize the table by following the linear programming model. Thank you.